Okay, today we're going to talk about exponentials and logarithmic functions. Get that out of my mouth. The definitions: an exponential function is in the form of f of x equals a b to the x, or y equals a b to the x. Remember, I told you f of x is just another way of writing y, where b is your positive constant other than 1, and x is a real number. Compound interest. We're going to be talking about compound interest, which is a form of exponential function. The formula for this is on your formula sheet, but you need to know what the letters stand for. A equals P times the quantity of 1 plus R over N, and the quantity raised to the NT, where A is the total amount of the loan, including the interest. P is the principal, how much you put in or how much you take out. R is your rate in decimal form. Please remember it has to be in decimal form. N is the number of times per year that this occurs, your interest is accumulated, and T is time in years. So if you have 6 months, you have to put half a year. And then we have continuous interest. That's interest that increases infinitely, meaning that it does it all the time. So A is still the total amount, interest, and the principal. P is your principal. R is the rate in decimal form. E is your natural base, and I'll show you where that is and how to use it. And T is still time in year. Your natural base is approximately 2.718, and there is a button on your calculator that does natural base or the E, so I'll show you where that is also. Okay, so here we go. We got a problem. 42.2, that's where we're starting at, 42.2. We're increasing it 56%. That's what that means, because everything starts at 100%. If I have a 1.56, it means I increased to 56%. So now I have 156%. So in our model, we're starting at, when you get there, for 0, you have $42.20. And then you increase 1.56% each hour you stay there. So I need to know what happens after 4 hours. So I have 42.2, 1.56 raised to the 4th power. Now let's talk about your calculator. Okay, on the TI-83, 42.2, parentheses, 1.56, parentheses. This is your power button right here, your carrot top, raised to the 4th power. My answer is $249.93. Now, please remember, let's see if I said that right, $49.93. Now, if you can't round on your own, your calculator rounds for you. You just go to Mode, Float, and I want to round it to 2 decimal places. I hit second mode, Enter, and it'll round it for me. If I want it out of rounding, I hit Mode, back to Float, second mode, Enter, and it's back out of rounding. So my calculator can do a lot of stuff for me. Just need to know how to use it. Okay, graphing exponential functions. This is an exponential function. On the left-hand side, you have a growth. You see how it's rising? That's what an exponential growth looks like when it's rising like that. This is an exponential decay because it's falling. The difference is this is a 2 and this is a half. Now remember, things start at 100%. So if I go up to a 2, I've risen to 200%. It's going to increase. If I go down to 50 or a half, 0.5, I've decreased. That's my decay. So you can tell if something's going to increase or decrease by your your B value. This is going to increase. This is going to decay. So that's a growth. I should call it by its name. It's a growth. I'm not sure about that one because it has a negative on the X. It's a little different. This is a growth. This is a growth. And I'm not sure what's going to happen with that one, so maybe I should wait on those. Okay, let's see what we got. I'm going to go to my graphing calculator. I'm going to put in 3 raised to the x power. Now, I could do this myself. I could put in 0, 1, 2. 0 is 1. 1 is 3. 2 is 9. Negative 1 is 1/3. Okay, I can do that, and I could do that all by hand, but I do have a graphing calculator, and if I hit second graph, it'll give me all my points, the same as I had previously. So if I have a graphing calculator, might as well use it as well. So -1 1/3, and I hope I can get that in there. 1 3 0 1 2 9, and as you can see, this is a growth. I can do the same thing with the 1/3. If I put 0 in, it's 1. If I put 2 in it, 1/3 squared is 1/9. If I put -2 in it, I flip that and it's 9. So see what I get on here. 0 1, 2 1/9. I don't know if I can get it that close, and -2 9. And as you can see, it's a decay. Now what's happening right here is these are asymptotes on my exponential, which means I'm getting closer and closer to 0, but I won't touch it. So that's what happens with an exponential growth. Now, from transformations, we should know that anytime you add to the x, you move it left. So this should be moving left. So we had 0 1 2 -1, 1 3 9 1/3. And if I move left, I'm taking one off of each of those. So let's see what the calculator says about this too. Y equals 3. Now, this has to go in parentheses. Otherwise, it's just going to raise it to the x. And then add 1 on, which is this equation. Second graph. So -1 1 0 3 1 9. Everything's moving from the position it's at. So this went down here, this went down here, and it keeps on moving into the position. Oh, let's go back again. So let's see how they moved again. So -1 became 1. So this became -1. 0 became 3. 1 became 2. And 2 did not become that. 2 became 27 because I needed the next one in line. So -1 1. 0 3. 1 9. And coming across. So everything moved to the left. From our transformations, we know that if it's added to the back, it moves up. So we had 0 1, and everything's going to be moving up. So when we do this and we look at it, I'm going to take these parentheses off. Now what it'll do is raise it to the x and then add 1. I get 0 2 instead of 0 1 because I moved up 1. 1 3 will be 1 4. 2 9 will be 2 10. Everything will move up 1, and this will run across the y equals 1 as an asymptote because everything moved up. So now what happens if I put a negative on the front? Well, we normally think it's going to flip. That's what we should think because that's what we learned so far previously. So let's see if it flips. And it did. So we're still running 0 -1, 1 -3, 2 -9, and it runs on the opposite side of the asymptote. But we didn't talk about what happens if we put a negative on the exponent. What does that do? So I'm going to go back here. I'm going to take out that negative. I might as well take it all out now since I messed it up. Okay, so 3 raised to the negative x Let's see what happens with this equation. Oh, it's not supposed to be 3. It's supposed to be 1/3. That would be a reason, too. 1 divided by 3 raised to the negative x. So it should be a decay because of the negative 1/3. And it flips to a growth. So what that negative does on the top is it makes it the opposite. So we have the regular growth happening. Back to this equation is this equation. Okay, the natural base is e to the x. Find the projected wolf population in 2010 if the formula for population is 1.26 e to the 0.247x, and the formula is based on the year 1978. Okay, so I'm going to get my formula first. 1.26 e to the 0.247, and I need to fill in the x. I'm in 2010, and it's built on 1978. So I have to figure out how many years I've already gone so I can put that amount of years in, and that's 32. Now, where do I find this on the calculator? Okay, so I put in my 1.26. Now I need my E button. If you look down the side, you see there's a natural log button right here, ln. Above it is an e to the x button, so you have to hit second, e to the x. Then the e will come up. It already starts your parentheses. Now do not put another set of parentheses here. You started your parentheses, so 0.247 times 32, and your parentheses here, because I want that entire thing in the exponent. So the answer is 3,412 approximately. Now, the reason I didn't round it up or take partial with the decimal is because I don't want partial wolf. So I went to the closest wolf there was. Okay, now we're going to do compound and continuous interest. Now, let me rewrite the formulas for you. A is equal to P times 1 plus R over N raised to the NT. Now you see the set of parentheses? It's very important. Otherwise, it'll just raise it to the N, and then it'll take it times it by the T. We need to have it both. This is your compound. Your continuous is A equals PE RT. Okay, you decide to invest $8,000 for 6 years, and you have a choice between two accounts. The first pays 7% per year, compounded monthly, and the second pays 6.85% per year, compounded continuously. Which one is better? Well, if we had the same amount of money and the same interest rate for the same time, continuous is always better. But we don't. So we need to do two different equations. The first one is our compounded. You invest $8,000 at a rate of 7%. Remember, it has to be in a decimal, 0.07. It's compounded monthly. N is how many times per year? Monthly is 12. Raised to the 12 times the number of years, 6. The next one is continuous. In continuous, it's A equals, your principal amount is $8,000, E raised to the rate. I know it already has a decimal in it, but you have to change that percent to a decimal by moving it 2 spaces to the left, times 6 years. Okay, so let's see what we get here. Let's start with the first one. With 8,000 parentheses 1 plus 0.07 divided by 12 parentheses raised to the parentheses 12 times 6 parentheses. enter. So I get $12,160.84. $12,160.84. 12,100. Oh, forgot already. $60.84. Continuously. 8,000. Pick up my E. Raise it to the 0.0685 times 6. $12,066.60. $12,066.60. Now, the answer question is, which is better? Compounded is better, because on the compounded I got more money. 12,160 compared to 12,066. Okay, you decide to invest $10,000 for 5 years at 8%. What is the balance if compounded quarterly? So I need the compound. Equation. And I want to do it quarterly. So A is equal to 10,000 times 1 plus 8% quarterly, 4 times a year, raised to the 4 times 5. And what is the balance if compounded continuously? A is equal to 10,000 E raised to the 0.08 times 5. Okay, so let's see what we get here. 10,000, 1 plus 0.08 divided by 4, raised to the 4 times 5. Oh, I forgot a 0. See how you can tell if you did something incorrectly? Because it made no sense. $14,859. $14,859.47. $14,859.47 is compounded quarterly. Okay, so let's clear that out. 10,000. Don't forget to pick up your E. Raised to the 0.08 times 5. Gives me $14,918.25. So it gives me $14,918.25. $14,918.25. So here's my answer to that one and that one. It doesn't ask me which one's better. It just asks me what my amounts are. But as you can see, continuous on this case was better because nothing changed in the interest rate, the time, or the amount of money. Just if you compounded it 4 times or continuously. And I told you continuously will always be better if there's nothing else that changes. Okay, composite and inverse function. A composite function is a function inside another function. For example, f of g of x. And we've talked about these as we went on already. Domain of a composite function, x is the domain of g and g of x is the domain of f. The inverse function is a function that is the inverse of another. It's designated by f of -1. So if you see f to the -1, it means it's inverse. And the horizontal line test is used to tell if the original function's inverse is a function rather than having to go through and find the inverse. Okay, so let's see what we got here. This little O here means the same thing as this. So if you see it that way, it means the same thing. It doesn't mean multiplication. If they want it to be multiplied, they'd have a solid dot in there. So what it wants me to do is take g of x, keeping x, and put it into f. So 3 times x squared plus 6 minus 4. 3x squared plus 18 minus 4. 3x squared plus 14. And the next one, it means the same as this. So they want me to take f and put it into g. So I'm going to take this and put it in here. So I have 3x minus 4 squared plus 6. This means 3x minus 4 times 3x minus 4 plus 6. So I'm going to have to FOIL. 9x squared minus 12x plus 16 plus 6. 9x squared minus 24x plus 22. Let's do this again. F of g of x. That's what it means. So when we take g and put it into f. So 5 times x squared minus 1 plus 6. 5x squared minus 5 plus 6. 5x squared plus 1. G of f of x. Take f and put it into g. 5x plus 6 squared minus 1. That would be 5x plus 6 times 5x plus 6 minus 1. I have to FOIL. 25x, maybe I should put my x on there, huh? 25x squared plus 30x plus 30x plus 36 minus 1. 25x squared plus 60x plus 35. So it's placing one inside of the other. In this case, they want us to keep x and place them in. Sometimes they'll give you a number to place in. Okay, to find it, the reason we're doing this is to find an inverse. You take one, once you find the inverse, to verify it, you take one and plug it into the other. So you take the inverse and plug it into the original to find out if it's an inverse. And this is how you find an inverse. You take f of x and you replace it with y. So y equals 5x. Then you switch the x and the y. So x equals 5y. You solve for y. Divide by 5. Y is equal to x over 5. This is my inverse. Now, to prove it's an inverse, what I do to prove it is I take the inverse and I plug it back into the original. So 5 times x over 5 gives me 5x over 5, or x. If x comes out, it's proven. I could also take this and plug it in here. It makes no difference if I take the original, plug it in the inverse, or the inverse into the original. But what's supposed to come out to prove it is that there's an x. So, change it to y. Switch the x and the y. Solve for y, so I'm moving the 2. Divide. So, f, well, how about if I do g, since we're doing g? G of negative x, that means the inverse, is x plus 2 over 3. Prove it. So I'm going to take this and plug it back in here. 3 times x plus 2 over 3 minus 2 crosses out. X plus 2 minus 2 crosses out. X. Proven. Change to y. Switch. Solve. So this is h of negative 1x. Prove it. Plug it back in. 7 times x plus 5 over 7 minus 5. X plus 5 minus 5. X. Proven. E would be nice. Y equals x to the third plus 1. Switch. X is equal to y to the third plus 1. Move the 1. X minus 1 equals y to the third. Cube root it. Y is equal to the cube root of x minus 1. Or that equals the inverse of f. Prove it. Third root of x minus 1, plug it in here, cubed plus 1. Wipes it out. X minus 1 plus 1. Gone, gone. X. Proven. So, We replace f of x or g of x or h of x with y. We switch the x and y. We solve for y. If the inverse can be plugged, and that should be your inverse if you didn't make any mistakes. But to verify it, take your inverse, plug it back into the original. If at the end all you're left with is x, you proved it. Okay, exponential functions and logarithmic functions are inverses. That's why we're talking about them in the same thing. So since they're inverses, we can switch them from one to the other. So this is how it works to change forms. Y, which is your answer, is equal to the log of b, which is your base. Let's start again. Y, which is actually over here, is your exponent. B is your base from over here. And x is your answer. So we switch it into that form. So this is what I like to remember. Base, answer. Let's go back. Keep messing this up, huh? Log of base, answer, equals your exponent. Okay, so my base apparently is 5. My answer is apparently 2. My exponent, let's try this again. I'm really messing up today. Okay, 5 is my base. My answer is x. My exponent is 2. My base is b. My exponent is 3. My answer is 64. My base is 3. My exponent is y. My answer is 7. Now let's go the other way. Log. My base is 12. My answer is x. My exponent is 5. Log. My base is b. My answer is 27. My exponent is 3. Log. My base is e. My answer is 33. My exponent is y. Now that I got it right, huh? Normal logarithms are based on the base 10. So if you do not have a base 10, you cannot use your calculator to solve it. So I'm going to show you a way to transfer bases to 10 as we go along. But here are 3 log rules you need to know because I'm going to be using them. If I have a log of base b and I'm multiplying 2 things, I can separate them with an addition sign. If I have a log of base b, or any log, and I'm dividing 2 things, I can separate them with a subtraction sign. If I have a log and it's raised to a power, I can take that power and multiply it on the front. And I am going to be using those rules as we go along. Okay, so here we go. We're going to switch everything over. Okay, if it doesn't have anything, just put an x on the end or y. Okay, so 2 is my base, x is my exponent, 16 is my answer. 3 is my base, x is my exponent, 9 is my answer. 36 is my base, x is my exponent, 6 is my answer. 7 is my base, x is my exponent, 7 is my answer. 5 is my base, x is my exponent, 1 is my answer. Now, notice all my x's are in the exponent. If x is an exponent, you bring x to the front and log both sides. So for me to solve these, if I didn't know them, I have to log both sides. What that means is I'm going to use that rule that says I can bring it to the front. And I'm going to take the log of 2 equals the log of 16. Divide by the log of 2. Now, I can use my calculator for this because I do not have a lower base anymore. So I can take the log, here's the log button right over here, the log of 16 divided by the log of 2 and get my answer of 4. Now you may have been able to look at that and know that the answer was 4. But we're practicing. If you didn't, this is how it works. The x comes out front, the log of 3 equals the log of 9, divide by the log of 3. Log of 9, don't forget to close your parentheses, divided by the log of 3, 2. So my answer, x, is 2. Bring the x out front. The log of 36 equals the log of 6. Divide by the log of 36. The log of 6, close those parentheses, divided by the log of 36, close those parentheses, equals 0.5. X is equal to 0.5. Now, I know for a fact x is 1 here. Okay, but if I needed to, it would be x log of 7 equals log of 7 divided by the log of 7. Well, the log of 7 divided by the log of 7 is going to be 1. I also know x is 0 on this one, because anything raised to the 0 power is 1, and the only way to get from 5 to 1 is to put a 0 in. But I could do x log of 5 equals log of 1 divided by the log of 5. My calculator is going to give me 0. Now, I previously said when I started logs up a minute ago, I told you the log function and exponential functions are inverses, and this is how I know. Besides being able to switch them around, if I take the line of y equals x and I place it in and I flip this over here, they'll match. Any inverse will be symmetrical across the y equals x line. So if I graph two inverses and I can put the y equals x in and they match, if I folded them over the y equals x line, then they would be inverses. Okay, to find the domain of g of x, the log of 4 of x plus 4, set x plus 3, set x plus 3 greater than 0. So therefore, x is greater than negative 3, or the domain is negative 3 to infinity. So you would take your answer portion and set it greater than 0. Okay, now we're going to natural logs. What's the difference between a log and a natural log? Well, a log with the base e is a natural log. Because we use this so often, they made it its own. So the only difference is it has an e. So when your calculator, when you hit the natural log button, it does the log with the base e instead of the log with the base 10. If you have the log with the base 10, you're using the log button. It's the difference. Okay? So to find the domain, you would take 3 minus x is greater than 0. Subtract 3. Negative x is greater than negative 3. Divide by negative 1. X is less than 3. X minus 3 squared is greater than 0. So that gives me x is greater than 3 when I solve it. Here are our domains. If you want to graph a natural log, you just go to y equals, you hit your natural log button, 3 minus x, and you graph it. And you see it's greater than 3. I mean, it's less than 3. Y equals x minus 3 squared. And you see it's greater than 3. So all we're doing is finding the domain. Okay, now I gave you 3 log functions to start with, and we are going to use those log functions. Okay, so this says I'm multiplying. According to my rule in the front, if I'm multiplying, I can split them apart with an addition. Multiplying, I can split them apart with an addition. Dividing, I can split them apart with a subtraction. raising to a power and dividing. For raising the power comes out front. And for division, I subtract when I split them. I'm going to expect you to be able to move them back and forth. So you need to know if you're splitting them and you're multiplying, you add, and you give them both the logs with a base. If you're splitting them and you're dividing, you subtract, you give them both the log with the base they have. And if you have an exponent, you bring the exponent out front, and then you give it the base that it has. Okay, so I have an exponent, goes out front. So it's 4 log 5, 7. This doesn't look like it as an exponent, but this square root means a half. So it comes out front, 1/2 the natural log of x. This goes to here and here, so the 5 comes out front of the 4 plus, because it's being multiplied, and the 5 comes out in front of the x. You could do 5 log of 4 plus log of x. That's okay too. Okay, so let's do another one. Power out front, 2 log base b of x. Times, I had to erase that because I couldn't see what it is. Remember, this has a power of a half. Times means plus, 1/2 log by. That's expanding. Got a lot here. We have, this has an exponent of a third. So 1/3 log 6x. We're subtracting because we're dividing, but we're doing both of them, so I need parentheses. 36 does not have an exponent, so log 6, 36. We're multiplying, plus 4 has an exponent, bring it out front, log 6y. Let's go the other way, let's compress. They both have log of 4, so the log of 4 comes out. They're being added, so it means multiply. 2 times 32. And if you want to go as far as log 4, 64, that's fine. They both have a log, so the log comes out. This is subtracting, so it's dividing. So 4x minus 3 divided by x. This has an exponent that has to go on, so that's the power of half. And this has an exponent that goes on, and this is multiplied. So log square root of x times x minus 1 to the 4th. This is an exponent that has to go on. This is a division. So natural log of x plus 7 to the 3rd power divided by x. This has an exponent that needs to go on. So does this one, and so does that one. This is division, this is division. So the log of b of x to the 4th divided by 6 squared divided by the square root of y. Now I could clean that up, but I just wanted you to condense it, and that's what it says to do, to condense it. Okay, change a base formula. The log of bm is equal to the log of m over the log of b. I told you the easiest thing for you to do, and I still agree with this, is change it to an exponential and determine where the x is. And then we'll determine what to do. So I'm going to put an x here. I'm going to do 5 to the x equals 140. The x is in the exponent, so you bring the x out front and you log both sides. It's the same thing as this, but why remember another formula? The log of 40, the log of 140, don't forget to close the parentheses, divided by the log of 5 is approximately 3.07. 7 equals x equals 2506. Bring the x out front, log of 7 equals the log of 2506 divided by the log of 7. The log of 2506, close that parentheses, and I can't emphasize that enough because people that don't end up getting definitely the wrong answer. It's approximately 4.02. Okay, using those rules, I bring 3 to the x minus 8 out front, and I log 2, and I log 16. I divide by the log of 2. So now I have 3x minus 8 equals the log of 16, close those parentheses, divided by the log of 2, which is 4. Move the 8, divide by 3, and x is 4. X is in the exponent. Bring it out front, log both sides. Divide by the log of 16. The log of 64 divided by the log of 16 is 1.5, so x is 1.5. X is on the top. Bring it out front. Log of 4 equals the log of 15. Divide by the log of 4. Log of 15 divided by the log of 4 is x is approximately 1.95. Bring the x out front. Log of 10 was the log of 120,000. Divide by the log of 10. The log of 120,000 divided by the log of 10. Approximately 5.08. In this case, I have an e here. So first thing I have to do is get the e by itself. So I get 40 e to the 0.6x equals 240. I divide by 40. So e to the 0.6x equals 6. Now what? Well, remember, e's opposite is ln. So what happens is if I want to get rid of an e, I have to ln both sides instead of logging both sides. So I'm going to do the ln of e and the ln of 6. This cancels out and I get 0.6x equals the ln of 6. ln of 6. So I have 0.6x equals the ln of 6 divided by 0.6. X is approximately 2.99. So if you have to get rid of an e, you have to ln both sides. So let's try another one. I pick up my 5 and move it over. I get 7e to the 2x equals 63. Divide by 7. E to the 2x equals 9. Now I need to ln both sides. Gone, gone. 2x equals the ln of 9. Divide by 2. So x is, the exact answer is the ln of 9 divided by 2. But if I want an approximate answer, the natural log of 9 divided by 2. 1.10. Because it's 1.098, which would go to 1.10. So if I need to get rid of something and there's an x on the top, I bring the x out front and I log both sides. But if I have an e, I have to natural log both sides. Okay, let's put them in their order. 4 squared equals x plus 3. This is the exponent. This is the base, so 2, and that's the answer. Exponent. I have to divide first. So that one's not, we're going to hold on to that one because that has more steps. Let's put this together. The log of 2, x times x minus 7 equals 3. So 2 to the third equals x squared minus 7x. Natural log comes out. I have x plus 2 over 4x plus 3 equals 1 over x. Divide by 6. E to the 12.77x equals 17.6. Natural log both sides. Go on. 12.77x equals the natural log of 17.6 divided by 12.77. So the natural log of 17 over 6 divided by 12.77. X is approximately negative 1.51. Okay, that's not correct. I put too many parentheses in. Seems strange. X is approximately 0.08. Okay, let's go back to this one. I don't know, I shouldn't have skipped it in the first place. This is 16 equals x plus 3. And I subtract 3, and 13 equals x. So that one was pretty easy once I put it in the form. This one, I have to divide the 3 first to get the natural log of 2x equals 4. To get rid of a natural log, you e both sides. So 2x equals e of 4. Divide by 2. X is the e to the 4th power divided by 2. And the e to the 4th power divided by 2 is approximately 27.30. So to get rid of an ln, we e both sides. Okay. 8 equals x squared minus 7x. Anytime I have an x squared, everything goes to one side. So x squared minus 7x minus 8 equals 0. So x minus 8, x plus 1 equals 0. X is 8, x is negative 1. So we're getting into all different kinds of things that we already did. Okay, let's go down to this one. Clear this outside room to do it. First thing I have to do is divide by 2,500. Oh, 25,000. So I have 500,000 divided by 25,000. And I get 20. So 20 is equal to 1.01 plus 0.09 over 12 raised to the 12t. Now, my variable is in the exponent, so I need to log both sides. So I bring the 12t out front, 12t, the log of 1 plus 0.09 over 12 equals the log of 20. Divide by the log of 1 plus 0.09 over 12 equal, and then that'll go away. So 12t equals the log of 20 divided by the log of 1 plus 0.09 divided by 12 is 400.93 divided by 12 again. T is 33.4 years. Now, when in the world would we use this formula? Well, if you look at the formula, it's the compounded interest formula. And what it does is it says, when will I have 500,000? If I put 225,000 in, I get 9% monthly. When will I get, how many years will it take me to get 500,000? So this is another way of using that compounded one and solving it. Now it's your turn to practice.